Welcome guys to part 2. So let's proceed our work. So as I showed you before, this is how an ARP request and ARP reply is going to look like. Anyway, so let's clean up this whole mess, erase, okay, and show the desktop. So let's jump to our so let's close Sencor here, quit. Basically, this is the program. Okay, as I showed you before, if we run this particular, so let me arp minus and pw, let me route minus n. So our gateway is 16.1. oh my god, duplicate. Anyway, so let's Python arp or IDS sig. So let me goes ahead and show you how can we detect this attack. Let's Control C, and as you can see here, the attack has been detected. So let's check the program. So basically here I'm importing the threading module, socket module, and struct module. You know what these modules do, and I have created some modules like the net info and my local IP. This particular, for example, the net info would, parse the procnet arp and the procnet route. For example, let me cut /procnet routes. This is the gateway. It's on the reverse order. If you think about it, my computer is the byte ordering. The default byte ordering is Little Indian, so this should be reversed. And if we Python import socket and call the socket inet, stand for internet addresses, network byte order to address, and we are going to decode this particular value to hex. As you can see here, this is the IP address of our gateway reverse, so you can add it to a list and reverse it as I'm doing here. Okay, so reverse it and join it. Anyway, this particular module would parse these two files, and it'll get the gateway MAC, the gateway IP, the iFace, the net mask, and so on and so forth. So it doesn't matter. So let's proceed our work, and I'm importing some other modules like Colorama, and from OS I'm importing sys command. I don't know why I am importing sys command here. I don't need it actually. So let's look for system. Okay, so we don't need this actually. Anyway, so I'm creating here an opcodes a dictionary just to print to the user that if we got an ARP request, we are going to print out who has instead of this value, and if we got an opcode of 0002, we are going to print is at. Okay, and the attacker will hold or will hold all the available attackers on the network, so we don't print this particular message repeatedly. Okay, basically here I'm creating an ARP class and I'm threading it, and the constructor will accept some. I'm going to instantiate the gateway IP, which is an acceptable parameter, and the gateway MAC, and I'm creating the socket instance. And if you remember guys, the socket instance is here we have the address family, and I am not using the address family INET stands for IP version 4, because if you don't use the packet family, and the packet family basically is nothing but a packet sockets, or the packet sockets are used to receive or send raw packets at the device driver OSI layer. So if you remember, an ARP request doesn't contain an IP, or an ARP packet doesn't contain the IP header, isn't it? So as you can see here, we have MAC header directly ARP header. So we are not, if we're gonna using the address family here, we will point to the internet, the IP header, we will point to the IP header. In this case, we need to find a way to point to the Ethernet header layer 2. In this case, we are going to be using the packet or the packet family. Okay, and when it is used along with raw sockets, raw sockets allows us to bypass the network stack, and it is good. So we are going to generate our packet from scratch. Okay, and I am here interested in the ARP protocol. Remember this particular ID, the ARP protocol ID, and each times we convert a host to network short, and this is takes 2 byte and convert it to the network byte order. And basically here I am going to receive data, and you can change the buffer here. You can set it 42, for example, if you're, because actually the length of an ARP packet is 42 byte, 14 for Ethernet header, 40, and I think it's 28 for ARP. Okay, 28, I think 28. Anyway, so here the run method that will be run right after instantiating the class object. I am going to parse to unpack the data. This is for de-encapsulation. Okay, I am going to, from that packet, I am going to unpack it. This is the network byte order, and if you remember, network byte order is big Indian, guys. And basically 2s, 1s are the data structure, how an ARP header is structured. Okay, so if you think about it, this is an ARP header and the hardware type is 2. Okay, and the struct module actually provides us a way to dealing with binary data. Okay, and for example, if we want to take from the packet the first 2 byte, we are going to specify it here. So you can put here H, and you can put 2s. 2s if the given value is a string. Okay, if you want it as a string. And here, as you can see here, 2s for 2 bytes, and 2s, 1s, 1s, and 2s, and 6s. This is the MAC address. 4s, 6s, 4s, 4 byte. Okay, anyway, so you got the idea, and we want to parse only the ARP header, so from byte 14 to 42. Okay, and here what I'm doing here, guys, I'm going to check if the opcode was 0002, which is an ARP reply, because the attacker will inject an ARP reply. We send us an ARP reply lying to us that the IP address of the gateway is related to its MAC address. Okay, so in this case we are going to check the source MAC address here, the source MAC address sent by the attacker, if it is a valid MAC address and it is related to it is the original MAC address of our gateway, because we already know the gateway MAC address, our gateway MAC address. Okay, and we are going to check its IP address, the gateway of the IP, and if this particular instruction evaluated to true, I'm going to print out this particular message and print the ARP request and print here the attacker's MAC address. So this could be the source as attacker is MAC. And finally here, just forget this particular function. I am going to get some information from the netinfo module, and here, guys, I am instantiating this is the thread object. So because we have threaded the class, and we are going to give it the gateway IP and the gateway MAC, and we are going to set it as daemon. So once we call the control C, we don't want the main thread to wait for other child threads to finish their job, so it exits immediately, and we are going to start it. Okay, so that's the program. If we run it again, here, as you can see here, the attacker MAC, and we basically go ahead, and so we don't have the gateway. I don't know, we still have a problem with our tool, but anyway, let's run it again. And basically, if we try to inject again, as you can see here, this is the packet, and let's take a look on this. So I'm going to give you an exercise, guys, I want to figure out which IP address is related to this particular MAC address. If you think about it, we have here on the opcodes, we can send a request reverse or a reply reverse. So RARP, or reverse address resolution protocol, is used to check for IP addresses related to MAC addresses. So try it out, and try to generate a request reverse ARP packet, and record a video and teach us. Okay, we are all learners. Anyway, so let me show you this particular how to generate a packet. Basically, here I'm creating the socket instance as I told you before, and I am going to bind to a given interface. This is the Ethernet header, so I am going to, and basically guys, the bin ASCII is a module. It has two main functions. The first method is unhexlify, and the other one is hexlify. Hexlify converts network byte order, or hexlify converts a network byte order to hexadecimal. And if we have some value like this, a hexadecimal, we want to convert it to a network byte order, we are going to use unhexlify. Okay, so as you can see here, this is 6s 6s h, and as you can see here, I haven't used 2s here because h here I have included it as as a value, as a hexadecimal value. So if you want to use here 2s, you have to provide it as follows, as hexadecimal. Okay, \x06. Excellent. Anyway, now we are going to generate our, as always, our ARP header, and this is the attacker, as I told you, will generate an ARP reply, and it will try to inject its source MAC address as the gateway's MAC address. Okay, and we will generate the ARP header. We will pack it here. We have unpacked it on the IDS, and we are going to pack it, or encapsulate the packet and give it the appropriate fields. And we are going to, just forget this particular bad command, I am going to generate the packet and send it over the raw socket. Okay, anyway, look at this. This is very good. I don't know why I did this. Anyway, so you can generate an ARP reply. This is I gave you some hints. This is the opcode 0x0003. So I wish you can solve this problem, guys. Thank you for viewing this video. See you next time.